Hi, in this video I will explain the rules for naming alcohols. Alcohols are organic compounds that have a hydroxyl functional group. The hydroxyl or the hydroxy functional group is the OH group. So whenever we have a carbon OH bond, then this indicates that the compound belongs to the family of alcohols. The most common alcohols that we use in everyday life are methanol or wood alcohol, ethanol or grain alcohol, propanol or isopropanol, which is rubbing alcohol. What are the IUPAC naming rules for naming alcohols? To name alcohols according to the IUPAC naming rules, first of all, we have to choose the longest chain of carbon atoms, including the OH group. And then we name it by replacing E, which is usually placed at the end of the name of an alkane, with the OL suffix. For example, in this case here, if we have this compound, then I can choose the highlighted chain, and in this case my compound will have 5 carbons and it's called pentanol. However, this chain is not the longest chain, because if I choose this chain, which is highlighted here, then it is going to be a longer chain. It has 6 carbons and it is hexanol. So this is the correct parent or main chain because it has more carbons and it includes the OH group. If there is a longer chain that doesn't include the hydroxyl group, then in this case we don't have to choose it and it's not going to be our main chain. For example, in this case here, we have 2 options. If I choose this highlighted chain, the number of carbons will be 7. But this chain doesn't include the OH group. So the carbon which is bonded to the OH group is not included in this chain. And that's why this is an incorrect longest chain. The correct one will be this one. Although this one has 6 carbons, but it has the OH group, and that's why this is the correct one. So we have to make sure to choose the longest chain, including the OH group, and that's why this compound will be a hexanol and not a heptanol. The second thing that we have to pay attention to is when assigning numbers, the priority is to give the OH group the smallest possible numbers. So we don't care about the branches at this point. We just care about the OH group. Just try to give your OH group the smallest possible number. For example, in this case here, the longest chain will be 1, 2, 3, 4, 5, 6. So this is hexane, but since it's an alcohol, this will be hexanol. And then I will try to give my OH group the smallest possible number, and that's why I have to count from the left side, because this will give the OH group the position number 2, and this is 2 hexanol. And then we have 1 branch here. This is a methyl group, and this methyl is at position 4, so this is 4 methyl 2 hexanol. The hydroxyl functional group position can be included within the name. So sometimes you will see in books or in exams that instead of naming it as 2-hexanol, we may name it as hexane 2-O. This is the same. This both are acceptable and both are correct names. If there are 2 chains with equal length, then you have to choose the chain which includes the hydroxyl group but with more branches. So for example, in this case here, I can choose the highlighted chain to be my longest chain. In this case, it will be a pentanol. This is at position 2, so this is 2 pentanol, and then the branch is 3 isopropyl. However, if I choose the other chain, which is this one now, yes, it's going to be pentanol, 2 pentanol, but in this case I'm going to have 2 branches, which are ethyl and methyl. According to the rules, if you have 2 chains with the same length, so pentanols in both cases, you have to choose the one with more branches. Since this one has 2 branches, whereas this one has only one branch, this is going to be the correct one. So whenever you have two chains with the same length and they both include the OH group, then you should choose the one which has more branches. Let's practice. For example, in this case here, let's say we are supposed to name this compound. I could choose this chain to be my longest chain. We have 6 carbons, so this is hexanol. And if I start counting from the left side, my OH group will be at position 3. If I start counting from the right side, it's going to be at position 4. So definitely I have to start counting from the left side, so this is 3. Now, in this case, I'm going to have 2 branches. We have an ethyl group at position 4, and then we have methyl at position 5. So this is one way for naming the compound. Now, someone might say that the longest chain will be this one here. 1, 2, 3, 4, 5, 6. Again, this is hexanol. And again, OH group is at position 3, so no change. However, in this case, we just have one branch, which is the isopropyl group. Since this naming includes two branches, whereas this one includes only one branch, then this is going to be the correct name. So it's going to be 4-ethyl, 5-methyl, 3-hexanol, which is B. So always make sure if you have 2 chains with the same length to choose the one with more branches. If numbering from both sides assigns the same number to the hydroxyl group, then we have to start numbering from the side which assigns the branches the smallest possible numbers. For example, in this case here, okay, I can name this compound. First of all, this is the longest chain, so this is 7 carbons, and that's why this is heptanol. If I start counting from the left side, my OH group will be at position 4. And if I start counting from the right side, my OH group will be at position 4. So it's the same thing for the OH group. However, if I count from the left side, the methyl group will be at position 6. And I'm going to end up with this name. Whereas if I start counting from the right side, my methyl will be at 2 and my OH group will be at position 4. Since this counting, this from the right side is giving us smaller numbers, then this is going to be the correct name, and that's why the correct name will be 2-methyl-4-heptanol. So if counting from both sides, just in this case, is assigning the same number to the OH group, then you have to look at the branches and try to give the branches the smaller numbers. If numbering from both sides assigns the same number to the hydroxyl group and to the branches, in this case you have to move to the alphabetical order rule. So the group which is written first should be given the smallest possible number. For example, let's say we were given this compound. Again, this is the longest chain, 1, 2, 3, 4, 5, 6, 7, so this is heptanol. Counting from left side or right side will give the OH group position 4. That's why this is 4-heptanol. However, if I count from the left side, my branches will be at 3, 4, and 5. And if I start counting from the right side, my branches will be also at 3, 4, and 5. So in this case, counting from both sides is assigning the same number to the OH group and also the same number to the branches. What should I do in this case? Since I'm getting the same numbers in different ways, in this case we use the alphabetical order rule. The group which is written first should be given the smallest possible number. Since ethyl goes first, then ethyl should be given the smallest possible number, and that's why this is incorrect, because I'm giving ethyl 5 and methyl 3, which is incorrect, and the correct name will be this one: 3-ethyl, 5-methyl, 4-heptanol. So always give your OH group the smallest possible number. If you are getting the same number, then try to give your branches the smallest possible number. And if your branches are also getting the same numbers, then use the alphabetical order rule to name your compound. Those rules should be followed in the same order. You can just memorize this by remembering these three terms: MBA, main chain, branch, and alphabetical order. Again, let's try to practice here. 1, 2, 3, 4, 5, 6, 7. So this is heptanol. All the choices are heptanol. Again, counting from left or right side, your OH group is at position 4, which is correct in all the choices. Now counting from the left side will give my branches position 3, 4, and 6. Without counting from the right side, they will be at positions 2, 4, and 5. Well, this is a smaller set of numbers. At least we have 2 here and we have 3 here. So this is going to be the correct one. So methyl will be at position 2 and ethyl will be at position 5, which is going to be as the correct choice. 5 ethyl, 2 methyl, 4 pentanol. So here we didn't have to use the alphabetical order rule because our numbers were different. Since our numbers were different, we just stopped at the level of giving the branches the smallest possible numbers. If the alcohols were cyclic, then in this case they will be called cycloalkanols, and the OH group will definitely be at position number 1. So this is cyclopropane with an alcohol group. This is cyclopropanol, cyclobutanol, cyclopentanol, and cyclohexanol. Always in cycles, your OH group will be at position 1, and that's why you don't have to put number 1 here. If we have branches, then the branches should be given the smallest possible numbers, but OH group will be always at position 1. So for example, in this case here, this is going to be 1, so this is 2, this is 3. If you count from the other side, there's going to be 1, 2, 3, 4, which is definitely incorrect. So this is a correct numbering, and that's why the correct name will be, in this case, 3-ethyl cyclopentanol. Again, this is 1. Now, if I count anti-clockwise, this is going to be 1, 3, 4. If I count starting clockwise, this is going to be 1, 3, 4. So I'm getting the same set of numbers, and in this case I have to use the alphabetical order rule since ethyl goes first. So this compound is cyclopentanol, and the branches are ethyl and methyl. The only thing which is left is numbering, and as I said, we are getting the same numbers: 1, 3, 4, 1, 3, 4. However, since ethyl is written first, so it should be given the smaller numbers. So 3 goes for ethyl and 4 goes for methyl. What about this one here? This is 1. Now definitely the closest branch is this one, so that's why this should be definitely number 2, and this is 4, and this is 5. If you try any other combination, you're going to get higher numbers. That's why this is going to be the correct combination, and the name of this compound will be, this is cyclohexanol, and the branches are ethyl and 2-methyl, so we have dimethyl here, and then we have ethyl here, and 2 and 5 are for dimethyl, and ethyl is 2, 4, and ethyl is at position 5. So this is 5-ethyl, 2, 4 dimethyl cyclohexanol. Finally, let's try to name this compound. Now we have chiral centers, so you have to pay attention to stereochemistry. Let's name the compound first. This is cyclohexanol, and definitely the branch is at positions 3. So this is 3-methyl cyclohexanol. We have 2 chiral centers, one at the OH group and one at the methyl group. This is 1, this is 2, this is 3. So this is R, so 1R. And then at this position, this is going to be 1, 2, 3. However, pay attention that group number 4, which is hydrogen, is not on the back. So 1, 2, 3, we're moving clockwise. This is S. but since 4 is not in the back, we have to use the crossing method. When you use it, then S will be R, and that's why this is going to be 3R, 3-methyl cyclohexanol. So this is how we name alcohols.